Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0A94 indicates a performance problem with the DC-DC converter in the Honda CRV models from 2017 to 2022. The DC-DC converter functions to convert high-voltage direct current, DC, from the hybrid battery to a lower voltage required by the vehicle's electronic systems. Its location is typically mounted near the battery, usually found within the engine compartment or under the dash, depending on the vehicle configuration. When performance issues arise, they may affect multiple electrical systems, leading to decreased functionality or activation of safety protocols. It's crucial for technicians to accurately diagnose this issue to maintain optimal vehicle performance and safety. The troubleshooting steps outlined focus on checking for related electrical and software failures to rectify this problem swiftly. The DC-DC converter primarily converts high-voltage DC from the hybrid battery system into lower-voltage DC used by the vehicle's electrical components. This converter plays a vital role in powering essential systems, including the infotainment and safety features of the Honda CRV. When diagnostic code P0A94 appears, it suggests the converter is not functioning within specified parameters. This can arise from various factors, such as wiring issues, internal faults, or connection weaknesses. The converter is typically located within the engine compartment, mounted in proximity to the hybrid battery. Correct operation of this component is critical. If it fails, symptoms may impact overall vehicle performance and driver experience. Several potential causes may trigger DTC P0A94. Issues with wiring can include shorts or open circuits impacting the DC-DC converter's function. These wiring problems often arise from physical wear, poor connections, or environmental damage. Additionally, the DC-DC converter itself may be faulty, preventing it from performing its vital function properly. It's essential to rule out a compromised communication link, such as a LIN communication error, which can lead to different DTCs being generated. Each cause must be methodically investigated to ensure the vehicle's electrical systems operate smoothly post-repair. Drivers may notice various symptoms related to DTC P0A94. A frequent indicator is the illumination of warning lights on the dashboard, particularly those signaling electrical or performance issues. Additionally, blown fuses in circuits linked to the DC-DC converter may occur, leading to further complications in vehicle performance. The vehicle may experience reduced power or inconsistent operation of electrical systems. If the auto idle stop system fails to deactivate when appropriate, this is a significant sign that further investigation is needed. Observations during normal driving conditions can guide the technician in pinpointing the underlying issues associated with the DTC. Begin by turning the vehicle to the on position without starting the engine. Use the Honda Diagnostic System, HDS, to clear any existing codes to reset the vehicle's system. This initial step helps to determine if the DTC P0A94 is a persistent issue or has resolved itself. After clearing, turn the vehicle off and proceed to test the auto idle stop system under normal operating conditions. This system should function by shutting off the engine at a stop. If the indicator blinks while the engine remains running, this suggests ongoing issues that require further investigation. These initial checks provide insight into the operational health of the systems involved. Utilize the HDS to check for any pending or confirmed DTCs. If DTC P0A94 appears, this indicates a known issue. Otherwise, proceed with fuse checks. Inspect the auxiliary under-dash fuse and relay box for any blown fuses that could explain the symptoms observed. If fuses are intact, investigate potential intermittent failures by checking for loose connections or corrosion at the DC-DC converter and powertrain control module (PCM) connections. A thorough inspection of these areas can reveal important clues about any weak or compromised links in the electrical system, contributing to the performance problem. With the HDS, evaluate the parameters related to the DC-DC converter status, CST. Specifically, observe the corresponding signals and current conditions to see if the values meet expected thresholds. This analysis helps identify if the converter is functioning correctly, as discrepancies may confirm faults. A yes response indicates that current conditions are aligned with expectations, which directs the technician to step 5. Conversely, a no response triggers a deeper investigation into the potential causes behind any issues, generally focusing on wiring integrity and other electrical aspects linked to the DC-DC converter. First, switch off the vehicle to the off-lock mode to prepare for testing. Utilize the HDS to jump the SCS line, waiting over 1 minute for accurate readings. Next, disconnect the required connectors, including the DC-DC converter connector A and the PCM connector A. Following these disconnections, a resistance measurement is taken between the designated test points, DC-DC connector terminals, and body ground. A reading of 1 megaohm or more confirms that the DC-DC STS wire is intact and in good shape. If the measurement is below this threshold, it indicates a significant issue, necessitating repair of the short on the wire between the PCM and the DC-DC converter. Once the vehicle is off, begin assessing the ground GND line by disconnecting the DC-DC converter connector B. Following this, measure the resistance between specific test points on the connector and body ground. A properly functioning ground should reflect a reading of 1.0 ohm or less. If the resistance exceeds this value, it indicates an open circuit in the GND wire linking the DC-DC converter and designated G352 point. Identifying this failure is crucial, as a weak or absent ground connection can severely affect the performance of the DC-DC converter and associated systems. Reconnect the DC-DC converter connector B after completing the previous checks. Once reconnected, switch the vehicle back to the on position and proceed to examine the inputs and outputs via the HDS. Pay close attention to the input-output error parameters for indications of malfunction. If any of the parameters register as malfunctioning, it suggests that the DC-DC converter may need replacement or further investigation into its input-output circuit. If parameters show as normal, this indicates that the lines are functioning correctly, but further verification of the DC-DC converter may still be warranted. Turn the vehicle to the off-lock mode to prepare for fuse inspection. Examine fuse number A11 for integrity. If the fuse is blown, this indicates an electrical issue within the circuit. Check for any shorts in the wiring leading from the DC-DC converter to this specific fuse, as resolving shorts is critical for preventing future fuse failures. In case of a blown fuse, replace it immediately. Following repairs, it's necessary to run diagnostic checks again to ensure that the original issues has been rectified, allowing the system to recover its functionality without further interruptions. This step involves confirming the condition of the +B DC-DC1 wire. Disconnect the DC-DC converter connector B before measuring voltage levels, ensuring that the current vehicle state is off, lock. Utilize a multimeter to assess the voltage between the specified test points on the connector and body ground. A successful reading should indicate battery voltage. If this is confirmed, The +B DC-DC1 wire is functional and should prompt consideration for replacing the DC-DC converter as the next step. However, if battery voltage is absent, it suggests an open circuit requiring necessary repairs before further diagnostics. While the vehicle is off, check the status of fuse number A43 within the system. If this fuse is blown, the next step involves determining whether there are any shorts causing the failure. Inspect the +B DC-DC2 wire to ensure robust connections and check for issues between the DC-DC converter and fuse. If repairs are required due to shorts or damage, complete them before replacing the blown fuse to avoid repeat failures. This thorough inspection aligns with the understanding of the vehicle's electrical layout and the essential task of maintaining secure electrical pathways. To finalize the check on the +B DC-DC2 wire, disconnect the DC-DC converter connector B again, ensuring the vehicle remains in the off-lock position. Measure the voltage between the designated test points on the connector and body ground. As with previous checks, a reading indicating battery voltage confirms the integrity of the +B DC-DC2 wire. In contrast, if this reading fails, it indicates an open condition that needs repairing. Follow through the necessary repair procedures to ensure reliable operation after these checks before concluding any steps related to the DTC. Upon completing all necessary repairs and replacements, it's important to conduct a comprehensive systems test to verify that all components are functioning as intended. This includes checking the DC-DC converter and related electrical systems for normal operation. After confirming the repairs, ensure that the DTC P0A94 has been cleared from the system using the HDS. Confirm there are no residual issues or DTCs present, verifying the overall health of the vehicle's electrical system. These final checks are crucial for ensuring customer satisfaction and vehicle reliability. To prevent occurrences of DTC P0A94 in the future, implement a routine maintenance schedule focusing on electrical connections and components. Regularly inspecting and cleaning connections associated with the DC-DC converter and the PCM can help ensure reliable performance. Additionally, keeping the hybrid battery well maintained prevents undue strain on the converter and surrounding electrical systems. By monitoring the overall health of these components, technicians can identify potential issues before they manifest as DTCs. Introducing preventive measures not only minimizes repair incidents, but also enhances the longevity of the vehicle's electrical systems. In summary, understanding DTC P0A94 is crucial for resolving DC-DC converter performance issues in Honda CRV models from 2017 to 2022. A methodical troubleshooting approach can significantly enhance diagnosis effectiveness, ensuring all potential causes are adequately addressed. By adhering to the outlined steps, technicians can identify faults accurately, paving the way for effective repairs while ensuring vehicle functionality and safety. Finally, implementing preventive strategies is essential for maintaining the electrical health of these vehicles, reducing the frequency of such codes in the future. These practices contribute to a more reliable driving experience and uphold Honda's reputation for durability. Please like and subscribe to the channel. See you next time.